I'm waiting for you guys. I'm waiting for you. I can't see any of you. Can you hear me? Okay, one person is here. Can we hear? Can we hear? Good evening, how are you? Can you hear me? Can you hear me? Can you hear me? Can you hear me? Can you hear? Okay, okay. Where are the others? Where did they go to? We don't have time. So they will join us. So now, let's start with Newton laws of motion. Are we together? If there is anything you need, please can just message. You can just drop it. The Newton first law is state that a body remains in a state of rest. Like if we have a body, this body will remain in a state of rest. Or assuming the body is moving with constant velocity, it will remain using that constant velocity. It will not increase, neither decrease velocity in a straight line. A body will remain in a state of rest or a uniform motion in a straight line unless an external force acts on its inertia. Unless there is an external force that acts on it, that acts on its inertia. The inertia that this body have is the reluctance to start moving or the reluctance to increase velocity. That is, it does not want to move or it does not want to change velocity. It's moving with constant velocity. That tendency that it doesn't want to move, that tendency of not wanting to move or wanting to change velocity, that's what we know as inertia. So unless there is a force that acts on that inertia, the body will continue to remain in a state of rest. Are we together? Or in a uniform motion in a straight line. That's everything about Newton's first law of motion. Now for the second law, that's when we begin to bring our formula. The Newton's second law states that the rate of change of momentum, I'm sorry, let's start with this. Momentum equals to, the definition is equals to mass of a body multiplied by the velocity at which the body is moving. The mass of the body multiplied by the velocity at which the body is moving. So momentum is mass times velocity. So there is something we call change in momentum. If a body of mass m1 is moving with initial velocity of u1, are we together? And it got to a point, that same body, let's just say mass m, let's not say m1, a body of mass m moving with initial velocity of u1. That same body now changes velocity. Let's call it, let's call this one u. We don't need that one. So it now change velocity to v. It changes velocity. So let's say this is the initial and this is the final. Since momentum is mass times velocity, so the change in momentum of this body now, the change in momentum equals to mv, the final momentum, which is mass multiplied by the final velocity. Are we together? Minus the initial momentum, which is mass multiplied by the initial velocity. Change in momentum. Since momentum is mass times velocity, if momentum is going to change, then we'll be talking of final momentum minus initial momentum to show that there is a change in momentum. So the final momentum gives us the mass multiplied by final velocity. The initial momentum gives us the mass times initial velocity. So if momentum is going to give us mass times final velocity minus mass times initial velocity. So that's change in momentum. Now, the Newton's second law now says the rate of change of momentum. So when we are talking of rate, that's when we have what? Over time. Are we together? So this formula is same thing as rate of change of momentum. MV minus MU over time taken. Are we following? Are we following? Um, can we send the comments to know if we are following? Are we following? I'm waiting for a response. Are we following? We are not talking. Are we following before I proceed? Okay, so thank you. This rate of change of momentum. So the second law, Newton's second law says that the rate of change of momentum is directly proportional to the applied force. And it takes place in the direction of the force. That is, this rate of change of momentum takes place in the direction of the force. So they say the rate of change of momentum is directly proportional to the applied force. Are we together? So at the end of the day, we can say F is directly proportional to what? M is common to both. Are we together? You can't see anything. Somebody said you cannot see anything. Maybe you should reload it again. I think that should be network. Because can you see it now? That should be network on your side. Because the other person is not complaining. Can you see it now? You can see it now. Okay, all right, thank you. So M is common to both. We have MV minus U, right? Over what? Over T. Are we together? So F is directly proportional. What is V minus U? This acceleration, that is final velocity minus initial velocity. If a body is moving with initial velocity and the velocity increase to a final velocity, there is an acceleration. The acceleration is the subtraction of both. So this V minus U is our acceleration. So we can conclude that, over time taking rather. Over time taking. So this can give us M V minus U over time taking. That's acceleration. Are we together? So F is directly proportional. Acceleration is velocity over time. Increase in velocity over time. And since V minus U is increase in velocity over this time, so that's what A. This guy is same thing as M multiplied by V minus U over T. So, and this V minus U over T is our acceleration. So at the end of the day, we have F is directly proportional to MA. So we can conclude that F equals to KMA. Are we together? That K is constant. You can write it as F equals to mass times acceleration. We all know this formula. That's how it's been derived. So that's force. But if you now want to find impulse using that same second law, that second law states that the rate of change of momentum, this is the rate of change of momentum, MV minus U over what? Over time taken, is directly proportional to the applied force. If we cross multiply, let's forget about this. Let's change it to equal sign. Since we have F equals to KMA, you can say F equals to MV minus U over what? Over time taken. If we cross multiply, we are going to have F times T equals to what? MV minus U. This FT is known as impulse. The unit for impulse is Newton seconds. So impulse is same thing as M multiplied by V minus U. That is, impulse is same thing as change in momentum. Because this is change in momentum. MV, if you open the bracket, MV minus MU, that is final momentum minus initial momentum. So we can conclude that impulse equals to change in momentum. We use this symbol to represent momentum, which is same thing as what? FT, and the same thing as what? MV minus what? Minus MU. Are we together? Please, is that understood? Is that understood? Because we are still going to solve a lot of questions and we are still going to discuss some concepts. The unit for impulse is Newton seconds. Newton seconds. MV minus MU is impulse. But if you have over time taken, that is force. They can ask you to find impulse force. Whether impulse force or any force, force is force. So the force is still something as MV minus U over T. This is force and it can still be impulsive force. But the moment you cross multiply and change it to MFT equals to MV minus U. So this one is impulse. why this one is impulsive force or any force. Is that clear? So we also have Newton's third law of motion. The Newton third law says for every action there is an opposite reaction. For every action there is always an equal and opposite reaction. For instance, if a body m1 moving with initial velocity u1, are we together? Okay, let's say that for every Newton third law say for every action there is always an equal there is always an equal and opposite reaction. So that's that for that. There is something I want to bring out there. There is a formula that says, okay, before that, let's move to, we are coming back to this. Let's move to conservation of momentum. Conservation. So that's when we will come back to this. Don't worry. Conservation of linear momentum. Please me just drop a comment. Conservation of linear momentum. We have which says the conservation of linear momentum states that total momentum. Let me use this symbol. This symbol means momentum. I'm using to represent momentum. Total momentum before collision equals to total momentum after collision. Total momentum before collision equals to total momentum after collision. Are we together? So that's conservation of linear momentum. And we now have we have types of collision. We have types. When we are discussing conservation of linear momentum now, we made mention of collision. Total momentum before the body collide equals to total momentum after they have collided. Now, types of collision. Types of collision. Number one, we have elastic collision. So this is where we'll be talking of some formula. Number two, we have inelastic collision. Inelastic collision. Now, please, can we hear me, please? Can we hear me, please? And is the video clear? Can we hear me? And is the video clear? Let's respond, please. Hello. Okay, all right, thank you. Now, elastic collision. In elastic collision, both momentum and kinetic energy. I'm using this symbol to represent momentum. Those momentum and kinetic energy are conserved. In elastic collision, both momentum and kinetic energy are conserved. If we say something is conserved and we are talking of collision, that means there is a momentum before collision and there is a momentum after collision. There is a kinetic energy before collision and there is a kinetic energy after collision. So if both momentum and kinetic energy are conserved, that means momentum before collision equals to momentum after collision. Total momentum before collision equals to total momentum after collision. Since we say under elastic collision, momentum is conserved. And we also say kinetic energy is conserved, means it does not reduce nor even increase. It doesn't reduce, it doesn't increase. So it's conserved. So this, when momentum is conserved, total momentum before collision, let me put total. Total momentum before collision is equal to total momentum after collision. For kinetic energy too, total kinetic energy before collision equals to total kinetic energy after collision. So that's the meaning of they are conserved. Now, before I move to inelastic, let me delete this guy from the way. Now, if we have two body, when we are talking of collision, that means we are not just talking of just one body, no. Because one body cannot collide with itself, isn't it? Can only have two bodies colliding with each other or more. But in this case, we are discussing two bodies. So let's say we have body M1 and body M2. Are we together? So before collision, let's say this before collision, and this, let's say this after collision. Now, before collision, this M1 will be moving with initial velocity. Let's call it U1. After collision, this one will also, before collision rather, before collision, the initial velocity of M1 will be U1. The initial velocity of M2 will be what? U2. After collision, it's possible they have common velocity if they stick together. But the one we'll be dealing with, based on your jam, this thing, there's no problem. Let's deal with, okay? Don't worry. If after collision, if they don't stick together, then this one we have final velocity after collision. This one too we have what? Final velocity after collision. This mass body 1, body 2. It's moving with initial. Body 2 is moving with initial velocity of U2 before collision. After collision, their velocity will change. If they don't, when they collide, if both of them still go their way, if they don't stick together, then that means body 1 will still have its own final velocity, body 2 will have its own final velocity. So for this type of collision, if we say momentum is conserved, and you know momentum is mass times velocity, so the total momentum before collision will give us mass times velocity, m1 times u1 plus m2 times u2, because the momentum of body 1 before collision is m1 u1 plus the momentum of body 2. The momentum of body 2 before collision equals to m2 u2. So these two before collision. No, momentum is mass times velocity. U is velocity. This is body 1. The momentum of body 1 before collision, the momentum of body 2 before collision, we said is equal to momentum after collision. That is m1 v1 final velocity now plus what? m2 v2. So this is the formula. If the body, they don't stick together, but assuming they have a common velocity after collision, that is if they stick together. Are we together? If they stick together after collision, now that they stick together after collision, they did not go separately, then we will not have v1 and v2. Both of them will have the same final velocity. Do we get? So it will now be momentum before collision will now be m1 u1 plus m2 u2 equals to what? m1 plus m2 multiplied by v. Why do we add the two mass together after collision? Because I say they stick together. So the two mass will be added together, multiplied by the final velocity. They will have a common velocity. So this momentum after collision when the two bodies stick together. When the two bodies does not stick together, so each of them will still have their final momentum. Now that they stick together, this will be the new formula. Momentum before collision, m1 u1 plus m2 u2 equals to m1 into v. Before I proceed, is this clear? Is this clear, please? Is it clear before I proceed? Let's talk. Is it clear? Hello? I'm waiting for our response. Is that clear? Okay, all right. Thank you for that response. Now we've discussed momentum is conserved. Now we also say kinetic energy is also conserved, which means total kinetic energy before collision equals to total Ke after collision. Total Ke before collision equals to total Ke after collision. Now, if we have the two body, M1 and M2, before collision, are we together? Before collision. No, this is not about this. Somebody is saying the first formula is just for momentum before. No, this M1 and U1, this guy is moving with velocity U1. The momentum of body A, this body M1, is M1 U1. The second body, the momentum before collision is M2 U2. No, this one has its momentum. As this body is moving, it has its momentum, M1 U1. As the second body is also moving, it has its own momentum. So the total momentum before collision is M1 U1 plus M2 U2. After they collide, If they don't stick together, then the velocity of m1 will change from u1 to v1. The velocity of m2 will change from u2 to v2. So we said total momentum before collision equals to total momentum after collision. For this one, total momentum before collision equals total momentum after collision. This after collision here is if the two bodies stick together. Now, if they stick together, they will move with just one velocity. Each of them will now have v1, v2 if they stick together. So this total momentum before collision equals to total momentum after collision. So to that guy, is it clear now? No, for kinetic energy now, before collision, for m1, kinetic energy is 1 over 2 mv square. Are we together? 1 over 2 mv square. But here we are talking of initial kinetic energy. So instead of using v, we are going to use u. So before the kinetic energy of this body before collision is 1 over 2 m1 u square. For body 2, the kinetic energy of body 2 before collision is 1 over 2 m2 u2 square. u2 square, sorry. So if we want to calculate the total kinetic energy before collision, total kinetic energy before collision is going to give us 1 over 2 m1 u1 square plus 1 over m2 u2 square. This is the total kinetic energy before collision. Now, after collision, if they stick together after collision, then total kinetic energy after collision will be equal to 1 over 2. Since the two bodies will stick together, so our total mass will be m1 plus m2. Since they stick together, they will now move with the same velocity, v square. So this is the momentum, this is the kinetic energy after collision, since the two bodies stick together. So since we say under elastic collision, kinetic energy is conserved, which means the kinetic energy before collision equals to the kinetic energy after collision. So we can conclude that 1 over 2 m1 u1 square plus 1 over 2 m2 u2 square equals to 1 over 2 m1 plus m2 all into what? V square. So this is for elastic collision where kinetic energy is conserved. Kinetic energy before collision, we have two bodies before collision. So this kinetic energy of the first body 1, kinetic energy of the second body, half 1 over 2 mass times velocity square. So the total kinetic energy is of the two body before collision equals to kinetic energy after collision. After collision, since they stick together, it's going to be the addition of the two masses, and they will move with the same velocity since they stick together. So that's that for that. But if they don't stick together, it will be this plus this will be equal to 1 over 2 m1 v1 square plus 1 over 2 m2 v2 square. So this will be equal to this if they do not stick together. But if they stick together, this will be equal to this. Is that clear? Is that clear? Is that clear? Is that clear? Are we together? So, let me check. I think, let's talk about proportion. Proportion. For proportion, yeah. Now, for proportion, change of momentum can be used as a means of proportion. If a body is moving with an initial momentum and the body changes, for instance, let's consider a balloon. If you have a balloon that you blow here inside, a balloon that has been inflated, and you just release it, the air molecules will rush out of the open neck of the balloon. Are we together? Then the backward movement of the escaping air is responsible for the forward. How can I put it now? If you blow air into a balloon and you just leave it, the balloon will be like it's rushing forward as the air in it is coming out. Do you get? The balloon will be moving forward as the air you blow inside of it is coming out. The air is coming backward, but the balloon is moving forward. That's what we understand by propulsion. So the backward movement of the escaping here is responsible for the forward movement of the balloon. For instance, if you have this a balloon, so if you blow air into this balloon, you blow air into it, and you just leave it. As the air is coming out backward, this balloon will be moving forward. We all know now, Shebi, we've used balloon. December, January, we used to blow balloon very well. So as the air is coming out, the balloon will be going. I hope we know that we have practicalized it before now as a children when we're still a young girl. And in fact, some of us are still doing it now. You just blow a balloon, I will just leave it. The balloon will be running here and there. As the air is coming out, the balloon is running forward. So that's what we understand by propulsion. So this application also take place in all these rockets. For rocket now, if you want to launch a rocket to the satellite or to the outer space, let's say this is the rocket now. Let's say this is the rocket. As what was it called now? The chemical inside the rocket, as it is ignite, something like fire will be like it's coming out. So as that thing is coming backward, it's pushing the rocket upward. It's pushing it upward. It's just like the application of something like to every action, there is equal but opposite reaction. That's this also makes use of application of Newton's third law. Like to every action, as this thing is coming backward, there is something that is pushing, is pushing forward. There is an equal reaction, but the reaction is in opposite direction to that action. This is an action. As the air is coming backward, then the reaction is on the balloon. The balloon is going upward. As this one is coming backward, the balloon is going forward. So for this action, backward action, there is a reaction that is forward. And the fact that the reaction is forward, that's why we say it is opposite to the action. For every action, there is an equal and opposite reaction. Are we together? So now, let's treat some question. Let me bring out. Do we understand that clearly before we move? So what you need to know is types of, for inelastic collision, this conservation, momentum is conserved, kinetic energy is conserved, is under elastic. Now for inelastic, this second one, for inelastic collision, only momentum is conserved. For inelastic collision, only I started like 20 minutes ago. For that guy that just dropped a comment, I started 6 p.m. But just join us. We have not solved calculation. I've only explained the notes, but I'm still explaining now. Just follow us. So only momentum is conserved. Only momentum is conserved for inelastic collision. For inelastic collision, only momentum is what? Is conserved. Is that clear? Only momentum is conserved for inelastic collision. Am I communicating? But kinetic energy is not conserved. These are the little notes you need to take care of. Kinetic energy is not conserved. It's not conserved. Only momentum. This is S. So if kinetic energy is not conserved, that means there is either loss or gain in kinetic energy, since it is not conserved. If it is conserved, there is neither loss nor gain. For momentum, under elastic collision, both momentum and kinetic energy are conserved. But under inelastic, only momentum is conserved. Kinetic energy is not conserved. Are we together? That guy should just follow us. That just join us. Just follow us. Don't worry. You will still get the previous thing that you've missed. But just make sure that you follow us now. Don't just follow us. This one will be much more better than you watching the video later. I'm going to upload the video. If you miss the beginning, you still watch it, but you are not going to lost. Just follow us now. Inelastic, note elastic, both momentum and kinetic energy are conserved. Inelastic, only momentum is conserved, kinetic energy is not conserved. So if kinetic energy is not conserved, that means there is either loss or gain in kinetic energy. But actually, in this case, there is no gain. It is always loss. Why? Because if two bodies are moving, initially are moving, this one is also moving. This one has its own kinetic energy, has its own kinetic energy. The total kinetic energy before collision will be bigger than the kinetic energy after they collide. Because after they collide, there is going to be a loss in energy. Imagine this guy is coming with an energy, let me say of 5 joules. This one too is coming with an energy, let me say of 4 joules. If they collide together, energy is going to be lost. They are not going to gain anything. For instance, if two of you are fighting, you want to blow yourself. This one is coming with a blow, you are coming with another blow. If you jam, if the two blows jam, you are going to feel weak, like you are going to lose strength. Am I communicating? Both of you are going to feel weak. You are not gaining any more energy. So as the two bodies collide, there is a loss in kinetic energy. Am I communicating? So since kinetic energy is not conserved under an elastic, so how do we calculate our loss in kinetic energy? Loss in kinetic energy, loss in kinetic energy, since kinetic energy before collision, before they collide, is greater than the kinetic energy after they collide. So loss in kinetic energy will give us total kinetic energy before collision minus total kinetic energy after collision. Is this clear? Loss in kinetic energy, since this one is bigger, so loss in kinetic energy will be total before collision minus total after collision. So it's going to give, loss in kinetic energy is going to give us 1 over 2 m1 u1 square plus 1 over 2 m2 u2 square minus 1 over 2 m1 plus m2 v square. So this before collision and this after collision, if they stick together. Is this thing clear to us? Please, is it clear before I proceed? Now, I'm waiting for a response. Is that clear? Let me bring out my textbook. Okay. Please, is it clear? Oh my God. Kinetic energy. Come. Okay, somebody said no, somebody said yes. In inelastic, in elastic collision, both momentum and kinetic energy is conserved. That means total momentum before collision equals to total momentum after collision. Total kinetic energy before collision equals to total kinetic energy after collision. But under inelastic, only momentum is conserved. So total momentum before is equal to total momentum after collision. But kinetic energy is not conserved. If I say something is not conserved, that means probably there is a loss or there is a gain. But in this case, we deal with loss in there is always loss in kinetic energy. There is no gain, because if two bodies are coming and they jam each other, a loss in energy. Am I communicating? There is going to be a loss in kinetic energy. Why? Because what is kinetic energy? Let me put it this way. Kinetic energy is the energy by virtue of your motion as you are moving. Potential is when you are in a state of rest. Potential energy is the energy by virtue of your position when you are in a state of rest. But kinetic energy is the energy by virtue of your motion. Before you talk about kinetic energy, you must talk about velocity. Because if you don't move, there's nothing like kinetic energy. Kinetic energy only takes place as you start moving. So as this body are moving, they have higher kinetic energy. But once they jam, their speed is going to be reduced. In fact, when they jam, there's going to be a reduction in their velocity. So as that result, we are going to have a reduction in kinetic energy. Do we get that? At the moment they jam, their velocity is going to be reduced. So once velocity reduced, kinetic energy will be reduced too. So which means there is a loss in kinetic energy. You cannot jam and yet your speed will increase. No. If you jam, your speed cannot increase. Your speed will rather what? If two cars are coming and they jam each other, will they increase in speed? No, there will be a reduction in speed. So as a result of reduction in speed, or in velocity rather, are we together? There will be a reduction in kinetic energy. So we talk about loss in kinetic energy, not gain. Kinetic energy is going to be lost. So how do we find that loss in kinetic energy? Now, we know that the kinetic energy before collision is greater than the kinetic energy after, because after collision they jam, they will have reduction in velocity. So if we now want to get the loss in kinetic energy, it's going to give us total kinetic energy before collision minus total kinetic energy after collision. So since the kinetic energy of the first body before collision is this, the second one before collision is this. So total will give us this plus this before collision. This is the total before collision minus after collision. Now the two bodies, they have jammed, they have collided. So we are going to add the two mass together. That's where I have M two mass together. And now they move with common velocity because now they have collided. Are we together? So this one is kinetic energy after collision. If you subtract it in this, then you are going to get the loss in kinetic energy. Judaya, do you understand now? So that's that for that. Now let's solve question. Let's solve little question. We are going to solve a lot of questions. Okay, before we start solving question, let me quickly deal with weight in a lift. Weight in a lift. Now, for weight in a lift, an elevator. If you have an elevator, this is an elevator, and somebody stand in the elevator, somebody standing on it. If the elevator is at rest, if it is not moving at all, are we together? Or if it's moving with constant velocity. If it's not moving at all, that means acceleration is equal to 0, right? And even if it's moving with constant velocity, that means acceleration is still what? It's still 0. Are we together? Because constant velocity means there is no increase in velocity, and we know that acceleration is increase in velocity. So if it's not moving at all, or it's moving with constant velocity, then there is something we call apparent weight. The weight of this body is acting downward, while the normal reaction, the reaction of the floor of that lift, are we together, is acting upward. The normal reaction is acting upward. The weight of this body, the real weight is W, but if you want to measure the weight of, as the body is standing, if you want to use scale to measure the weight, the scale will not measure the real weight. It can measure the real weight in a case if the lift is at rest or it's moving with constant velocity. It can measure the real weight. Are we together? But assuming it's moving, it's going to measure the apparent weight. The apparent weight is our normal reaction between the floor of the lift and the leg of the guy. That's the normal reaction, is the apparent weight. So our apparent weight equals to mg, the weight of the body. Okay, the apparent weight now equals to W plus MA. Are we together? And since our A is 0, since it's not moving or moving with constant velocity, so we can say our apparent weight equals to what? W. Because mass times 0 is equal to 0. So note, when the lift is not moving at all, or if the lift is moving with constant velocity, once acceleration is just 0, then the apparent weight equals to the real weight of the body. R, they will always ask you to find the weight experienced by the body. The weight experienced by the body in that lift is this R, which is the apparent weight. So equals to what? Mg. Since it's not moving or it's in but if the lift is moving downward with an acceleration A, if this lift is moving downward with an acceleration of A, so the apparent weight is going to give us the weight of the body plus mass times acceleration. So the apparent weight is going to give us what? Mg plus, is it plus now? No, it's minus. Sorry. If the body is moving downward, our R is going to give us W minus what? MA. Okay, I've heard you. I will recap, no problem. So that means R, so you can conclude that R equals to Mg minus what? MA. Let me find a big case. Now that lady that said I should recap, just listen now. We have 4 scenario. Scenario 1. Now the second scenario. Now listen now. The third and the fourth scenario. This weight in a lift, just understand the concept. We have 4 scenarios. For the first scenario, when the body is at rest, this video is just when the body is at rest or constant velocity. The first scenario, when the body is at rest or constant velocity. Are we together? So if a body is at rest or moving with constant velocity, that means acceleration is equal to what? Is 0. So the weight that, since it's not moving, the weight that this guy will experience, the experience weight is known as R, normal reaction, is equal to what? M is equal to mg. Yeah, plus ma. It can be minus, it depends. Now, the experience weight will now give us what? Mg. The mg is the weight of the body, no w is mg, plus m, since our a is 0, it's not moving. So that means the weight experienced by the body in that lift will give us what? The weight of the object. No w is mg. The weight experienced or the weight measured by a scale. Let's say, if assuming this floor is a scale that I want to measure the weight of this body, so the weight measured by that scale, the reading, the apparent weight, will give us the weight of the body. If the body is at rest, if the lift is at rest rather, or the lift is moving with constant velocity. But if the lift is moving upward, assuming the lift is moving upward, there will be something like how can I put it? The floor will feel more heavy under the foot of that person. The floor will feel more heavy under the foot of that person. So just if the body is moving upward, our R equals to, if it's moving upward with an acceleration A, there's an acceleration and it's not 0. If it's moving upward, if there's an increase in velocity, if it's moving upward with acceleration A, our experience weight now will give us weight of the body plus mass times acceleration. If it's moving upward, the weight that the guy will experience will be bigger, will be heavier. So it's going to give us its weight multiplied by mass times acceleration. So which is something as mg plus ma, which is something as m into what? G plus a. This is if the body is moving upward. But if the body is moving downward with acceleration a, then the weight experience is going to give us the weight of the body minus ma. You don't really get it. If it's moving upward, you are hardened. If it's moving upward, that will be measured, the weight experienced by the body will be heavier than its original weight. Yeah. Yes. There will be heavier weight as it's moving upward. So it's going to be addition. If you are moving downward, listen, this is just a real error now. If you are moving downward, you are going to feel less weight, isn't it? That's why for downward motion, we are subtracting, because the weight is going to be lesser than the original weight of the body. If you are moving upward, it will be much more heavier. It is very hard for you to throw a stone upward than for you to leave the stone to be jumping downward. It is much more harder to throw a stone upward than leaving the stone to fall down, right? So if you are going upward, there's going to be more weight. It's going to be more heavier. So that's why it's going to be the weight of the body plus mass times acceleration. For upward, just is that idea. If it's coming downward, it's going to feel less weight. The weight is going to be lesser. That's why it's going to be R. The experience weight now will give us W minus what? MA. Are we together? So it's going to give us mg minus what? Ma. Am I communicating? So it's going to be, the experience weight now is going to be what? M into what? G minus what? A. For downward motion is subtraction. For upward is addition. For constant velocity or at rest, the R equals to the weight. Now, for this one, if the body is moving with under acceleration due to gravity, if the body is moving under free fall, if the acceleration of the lift, the lift rather, not the body, if the acceleration of the elevator If I've mentioned body before instead of lift, I meant lift too. If the acceleration of the elevator is same thing as acceleration due to gravity, then R will be what? Is 0. This is what we know as what? Weightlessness. As the acceleration of the lift equals to acceleration due to gravity, then this guy will not feel any weight. How is R equals to 0? R equals to M. Downward motion is what? Mg minus what? Ma, right? Are we together? Mg minus Ma. So we have what? R equals to Mg minus A. Are we together? So R equals to M. Since we say A equals to G, if it's moving in acceleration that is equal to G, then we can replace our A with G. Are we together? G minus G. So it's equal to M. G minus G is what? Is 0. So then M times 0, we get what? 0. So our R equals to 0. So take note of, those are the four scenarios that we have. Take note of them. If it is at rest, then R equals to W, R equals to mg. If it's going up with an acceleration A, then the weight experienced by the body, the weight measured, with the apparent weight equals to what? Mg plus ma. If it's coming downward, the apparent weight is mg minus ma. If it's coming downward with acceleration that is equal to gravity, then the what? If it's coming down with acceleration that is equal to gravity, then the experienced weight will be what? Will be four scenario clear to us. Please, is it clear? Please, are all these four things clear? Is it clear? Is it clear? Before we proceed, I'm waiting for a response. Is it clear? Everyone? Hello? Hello? Is it clear? Is it clear? Wait in a lift. Is it clear to us now? We are not answering. Okay, all right. Thank you for that response. Now let's solve a few questions. Now I have this is a question. Let's solve question. Now this question says, most of these questions are jam questions. So now a body of mass 8 kg moving with a velocity of 30 meters per second due west. Now a body of mass 8 kg. A body of mass 8 kg. So let's call the body M1. M1 equals to what? 8 kg. Are we together? Moving with a velocity of 30 meters per second, U1 equals to 30 meters per second. Are we together? Due west, hit a stationary body of mass 6 kg. Another body. So this body hits or it collides with a stationary body of mass 6 kg. So there's another body, 6 kg. So the mass of that second body we bought is 0. Why? Because the question says it is stationary. It is on a spot. It's not moving. So the velocity of the second body, this 6 kg, the initial velocity will be 0. So if they move together after collision, which means they stick together, they did not separate. If they move together after collision, that means since they move together, that means they are going to have common velocity. There is no V1 or V2. They are going to have V since they move together after collision. Are we together? Then now say the velocity, the value of the velocity is the velocity at which they move together. Now, you know the formula that says M1 U1 plus M2 U2 equals to what? M1 plus M2 into V. Since they move together after collision, they stick together after collision and they move together like they did not separate. So we are using this. The two mass now will be together. So there is nothing like V1 or V2. Since they move together after collision, they will have the same velocity. Their mass will be added together. So we are going to use this formula now to find. We are asked to find that velocity at which they move together after collision. So what's our M1? 8. What's our U1? 30. Plus what's our M2? 6. What's our U2? Is 0. Are we together? And another thing you need to take note is that there is no problem. Equals to M1 8 plus 6 into what? Into V. So 8 times 30 we have 240 plus 0 equals to 8 plus 6. We have 14V. So 240 equals to 14V. So V equals to what? 240 over what? Over 14. Are we together? Where's my calculator? I'm coming. I want to get my calculator. 240 over 14. Hey, shit. Oh my God, my calculator is not here. 2 divided by 14. Whatever you get is your answer. Meter per seconds. Please, is that clear? Oh, thank you very much. 17.143. Thank you. So velocity is equal to what? 17.143 meter per seconds. Is this understood? So that's question 1. Now question 2, I want us to solve like 15 questions. Then we end the class. We've dealt with the note aspect. Go and learn those theory aspects. Now this calculation. Now question 2 says a body of mass. See question 2. A body of 12 kg. A body of mass 12 kg. M1 equals to 12 kg. Moving with a velocity of 18 meter per second. So U1 equals to 18 meter per second. Are we together? Due east. Due east. Hit a station 10 kg. M2 equals to 10 kg. Since M2 is stationary, that means U2 will be what? 0. Since it's stationary. I'm using calculation in physics. And these questions are JAMB questions. Some of them are WAEC, some of them are JAMB. So this calculation in physics, it is very good for JAMB. Very, very good for JAMB. Are we together? By Omotosho HO. So at the end of the day, we are asked to find what? The question now says, if they move together after collision with a velocity v due east, find the value of v. Since they move together after collision, so we are going to have M1 U1 plus what? M2 U2 equals to what? If they don't move together, if they move separately, so you have to take note of how the question is being given to you. If they move separately, you are going to use this formula. This one. If they move separately, they are going to have their unique final velocity. But because they move together, this is the one we are using. Do we get that? So this guy is going to give us M1 U1 plus M2 U2 equals to what? M1 plus what? M2 into what? Into V. Are we together? So at the end of the day, what's our M1? 12. Our U1 is 18 plus M2, 10 times 0, we get 0 here, equals to M1 plus M2, 10 plus 12. I'm coming. 10 plus 12. 10 plus 12 equals to 22. Don't worry, I'll use another question to re-explain. So 12 times 18, right? That's 204 equals to 22V. So V will give us what? 204 divided by 20 what? Divided by 22. 12 times 18 is it 204? Am I right? Because my calculator is not here. Am I right with that? 216, Abi? Wow. 12 times 18 is 216. 10 times 18, 180. Oh, sorry, 216. Oh, sorry. Don't mind me. 216. Thank you for that observation. So this is what? 216 over 22. So whatever you get, meter per second. That's their common velocity. That lady that said that she will explain, don't worry. I'll use another question to re-explain now. Now, another question says, 9.818. Thank you for that. I'm coming. Let me see if I can on touchlight. Oh, my phone is very low, 10%. I will have to rush this thing. So a man of mass 120 kg. Another question says a man of mass 120 kg. This thing is becoming blurry. Let me see how we can do it. we can actually do part 2. But let me see if I can on my. Okay, the touch cannot on. Is this still clear now? Can you see it clearly now? Can we still see it clearly? So another question says, a man of mass 120 kg. The mass of the man is equal to 120 kg. 120 kg. Jumps with a horizontal velocity of 8 meters per second. U equals to 8 meters per second. Are we together? Onto a stationary skateboard. Okay, let's call this M1, U1. Onto a stationary skateboard of. So in case if you are watching the video later, if you need the question I'm solving now, I'm solving question 13 now. So you can just screenshot question 13. Jumps onto a stationary skateboard of mass 4 kg. So our M2 equals to 4 kg. Since the skateboard is stationary, U2 will be what? Is 0. So what is its velocity as it moves off? As he moves off on the skateboard, that means the skateboard and the man moves together. So what will be the velocity? So they will have common velocity. So will you still apply that same M1? That leader said I should explain again. These are momentum before collision is M1 U1 plus M2 U2 equals to what? M1 plus M2 into what? Into V, since they move together. So what's our M1? 120. What's our U1? Times 8 plus what's our M2? 4. Our U2 is 0 equals to our M1 is 120 plus what's our M2? 4 into what? V. So here 120 times 8 times 8, that's 960, right? Equals to 120 plus 4, 124 V. So V will give us what? 960 divided by 124 meter per second. That's the velocity. Is this clear? Now we are done with that aspect. Let's move to another aspect. Now, come and see another question here now. Yeah, thank you. This one says, a man, thank you, 7 point, so this gives us 7.74 meter per second. Thanks for that. Now, look at this question. It says, a body of mass 85 gram, question 15. M1 equals to 85 gram. M1 equals to 85 gram. Move with a velocity of 8 meters per second. U1 equals to 8 meter. U1 equals to 8 meter per second. Collide with a wall. No, they don't need to tell you that the wall is stationary. Does a wall move? No. A wall is always stationary. Collide with a wall. If after the collision, it moves. Yeah, it's clear now. It's clear now. Is it clear now? If after the collision, it moves with a velocity of 3 meters per second. Is it clear now? That little guy that said is blue. That guy that said is blue. Which question am I even reading? Yeah. Collide with a wall. A body of mass 85 gram move with a velocity of this. Collide with a wall. If after the collision, it moves, okay, thank you, with a velocity of 3.0 meter per second. Now, what are they talking about now? They say if after the collision, okay, we don't even need the wall again. They are still referring to that same body. That body, that 85 gram body, as it's moving with velocity of 8 meters per second, the body collides with a wall. After the collision, that same body moves with a velocity of. So here we have now U2 is equal to 3 meters per second. But since the question says, why is this thing blur? Since the question says in opposite direction, so this second velocity is going to be negative. They say if after the collision, it moves with a velocity of 3.0 meters per second in opposite direction. Are we together? So this is going to be negative. The question now says, The question says calculate. Yeah. We just do 2 more questions and I will end the class. Then we solve in the next one that we'll be doing, we solve calculations alone. It's because we've explained. I did not bring my thoughts, so sorry about that. We've explained a lot of notes. So when I upload the video, make sure you watch the first aspect. Those notes are very, very much important. So in the next one, we use to solve calculations, like pure calculation. So they say calculate the change in momentum. Calculate the change in momentum. Let's call this. So this is the body. Since it is not two body. Now, since it is not two body, just one body, so we don't need to put M1. We can only put the mass equals to 85 grams. Then the body is moving with initial velocity of what? 8 meters per second. Then when the guy collide with a wall, then there is another velocity, which is what? 3 meters per second. But the question says the second velocity is in opposite direction. So we are now asked to find the change in momentum. What is change in momentum? Change in momentum is equal to what? mv minus what? mu. Are we together? mv minus what? mu. So in this case, what is our mv? This guy is going to give us mass. What's the mass? 85 grams. Are we together? Convert it to kg. That's 85 divided by 1000. It's going to give us 0.085. Am I right? It's going to give us 0.085. Yeah, that should be correct. So I'm going to add 0.085 multiply by v is 0.85. Is 0.85, not 0.85. Yeah, multiply by v. What's our v? Minus 3. Are we together? Minus 3 minus mu is 0.085 multiplied by u. What's my u? My u is what? 8. Are we together? So at the end of the day, I will have 0.085 into minus 3 minus 8. I think something should be something. So this guy is going to give us 0.085 minus 3 minus 8 minus 11. Minus 11 times 0.085. What do we get? So that we end it here. It's becoming dark. Minus 11 times 0.085. What do we get? Minus 11 times 0.085. So that gives us negative what? 0.935 kg kg meter per second. That's the change in momentum. Are we together? That there is a reduction in momentum. This like the how can I put it now? This minus sign shows that the final momentum is moving in opposite direction rather to the initial momentum. This minus sign shows that the final momentum is moving in opposite direction to the initial momentum. So we end it here tonight because it's getting dark. I enter school because of network and I forgot my touch at home. Very sorry. In the next one, we are going to solve a lot of calculations, like a lot of calculation. Let me see if I can give you assignments. Let me see if there's a way I can give you assignments. To just try. Okay, you are welcome. You are welcome. This is becoming darker. Oh my God. Let me see if it can become clearer a little bit so that I can just screenshot. Is this thing clear enough? Not at all. Not at all. It's not clear. Okay. Maybe I will send it to the group. The most important of today's class, what is important much in this today class is the theory aspect I explained. So please, once I upload this video tomorrow, make sure you watch it. Make sure you watch it for the theoretical aspect. So probably that same tomorrow, we will use the maybe 1 hour to do the remaining calculation. I have up to 20 calculations here, and if you can finish all the calculation, if you can finish it, then you should not have problem again with this topic. Are we together? So good night. Thank you very much. Don't forget to subscribe if you are here to subscribe to this channel. And once I upload it tomorrow, drop a comment. Thank you. Good night. Don't forget subscribe. Good night, oh. Good night, oh. Please, I repeat, those explanations are very, very much important. And that weight in a lift, even though we don't have time to solve a lot of calculation, those 4 scenarios of weight in a lift, those explanation of conservation of linear momentum, and the rest, they are very, very, very much important. Oh, I think there is light here. They have one light. Let me show you the calculation. Wait, they have one light here. Let me show you the assignment. Then in the next class, you will drop your answer in the comment section. Don't good night yet. I'm coming. Let me give you assignment. They have on light. Let me give you assignment. Then in the next class, you are going to drop your solution in the comment section. Then we continue. I'm coming. Just wait. Don't worry. There's light here now. So that, some people, they are not in our group and they will later watch this video. So you can try this assignment yourself. It's cool. I think you can all see it now. I'm coming. Now just screenshot it. Solve number 16, number 17, number 18, and number 19. 16, 17, 18, 19. Solve 16, you can screenshot it as I'm showing you now. 16, 17, 18, 19. You can just find your way to solve it. I will still repeat it in the next live class so that when I'm solving it, then you have more understanding about it. So just 17, 18, 19. So you can just screenshot it like that. Are we done? Can I cut the video? I hope we've all done the screenshot. We've all done the screenshot. All right. Thank you. Good night. Love you all.